Hello friends, welcome to our YouTube channel. Now in today's class we will discuss about the intensity distribution about the ara- interference of the wave. Okay, so let's start with the intensity distribution. So first we have to discuss about the waves. Okay, so when we are considering the single wave, observe here the single wave, it is represented here with the equation y is equals to a sine omega t, where y is the displacement of the wave, a amplitude of the wave, and omega t, it is the in time t the angular displacement theta and velocity omega. Okay, so here omega represents the angular frequency also at time t. Okay, and these arrows, this will represent the different positions of the particle during the wave motion. Okay, now here see the next diagram. In this diagram the interference has been shown. Okay, so two waves when they interfere, such type of pattern will observe there. So we are considering here two sources S1 and S2 and a point P which is equal situated from the both the sources. Okay, so as shown here, the path of the first source, it will be S1P, and path of the wave from the second source, it will be S2P. So here observe clearly, here we are getting the same path wave or path length, that means S1P, here it will be S2P. Means path difference in this case it will be 0 because both the distances are same. Okay, so observe this diagram here. I have shown with the help of two waves, different waves from two sources. Okay, more clear diagram. Here the source S1 and source S2 are represented here. The wave take the same time to reach at point P. Okay, so waves will arrive in phase. In such conditions, when they are taking the same time, they arrive in the same phase. Means their phase difference will also the 0 in this condition. Okay, so the displacement produced by the source S1, if we represent it as a y1 at point P, then y1 can be represented according to wave equation, that will be a sine omega t. And the second source, it also emit the same wave, so the displacement y2 can be represented as a sine omega t. Both the waves are same, so amplitude same, omega t remains same. So y1 a sine omega t, y2 a sine omega t. So the resultant displacement when they meet at a point P, then resultant displacement can be written as y is equals to y1 plus y2. रिझल्टंट कसा काढतात, दोन्ही ज्या पॉइंटला येऊन मीट होतात त्या पॉइंटला दोघांचं ॲडिशन करायचं, वेक्टर ॲडिशन वी आर डुईंग. सो हियर वी विल ॲड दिस. सेम फेजमध्ये ॲड होतात म्हणजे तिथं कंपल्सरी ए प्लस ए ॲम्प्लिट्यूड पॉझिटिव्हमध्येच असणार आहेत, सेम फेज असल्यामुळे. सो ए प्लस ए 2a होणार आहे. सो हियर वी आर गेटिंग द resultant wave as y is equals to 2a sin omega t. Okay, so the intensity of a wave is directly proportional to the square of the amplitude. We know that already. Intensity of a wave is directly proportional to the square of the amplitude. So इथे जो resultant wave मिळाला आपला y is equals to 2a sin omega t, याची intensity how we can represent here? I is proportional to amplitude, here it is 2a. So I proportional to 2a, it's a square. Okay, now if I naught is the intensity of individual waves, means if from the source S1 and from the source S2, if the waves having the intensity I naught, then I naught is proportional to a square, because each equation y1 and y2 is a sin omega t. So at that time intensity will be a square. Okay, so I naught is proportional to a square. Now if we take the ratio of these two, resultant intensity and the original intensity, here we get that I divided by I naught is equals to 4a square divided by a square. So we will get here that I divided by I naught is equals to 4 divided by 1, means the ratio is 4:1, and the final intensity, resultant intensity is 4 times the previous intensity of the two sources, because two sources having the same intensity, so 4 times of any of the source we can take. Okay, so 4 into I naught. Now here we'll see the next slide, in that slide I have shown that the another condition, that is the point P situated arbitrarily at any position. Okay, so observe here. Now this point P creates the phase difference between these two waves. Now source S1, it will having the displacement equation as y is equals to a1 sin omega t, and S2 source, now it will have the wave equation as y2 is equals to a2 sin omega t plus phi. Okay, phi represents here phase difference between these two waves, and waves having the different amplitude a1 and a2. Okay, so in this case first we'll find the path difference or the resultant displacement. Okay, so here y1 can be represented as shown in the equation here. Y1 is a1 sin omega t and y2 is a2 sin omega t plus phi, where what is phi? Phase difference between these two waves. Okay, now how to find the resultant wave again for this condition? Addition of these two waves y1 plus y2 will give you the resultant displacement. So what is y? Y1 means a1 sin omega t plus a2 sin omega t plus phi. Okay, now we require to solve this equation. Now how to solve? Sin omega t plus theta, that means sin of c plus t. So we will solve this by that equation. So what is the solution? The first term remains as it is, a1 sin omega t plus a2 into the bracket sin omega t plus phi can be written as sin omega t cos phi plus cos omega t sin phi. Okay, sin a plus b म्हटलं तरी चालेल त्याला, sin a cos b cos a sin b. Okay, from that formula we are solving this, we are getting this step. Now open this bracket, multiply a2 to each term. So a2 चं multiplication each term मध्ये केल्यानंतर next step आपल्याला काय घ्यायचं आहे की we are connecting or we are collecting the similar terms together. So similar terms means sin omega t terms together and cos omega t terms together. So out of this we are getting here that a1 sin omega t plus a2 sin omega t cos phi. These are keeping together, and the next term it is a2 sin phi cos omega t. It is only the single term, so keep it aside. Now in the similar term sin omega t, keep it as a common. So sin omega t, if we take it common, then we are getting here y is equals to a1 plus a2 cos phi sin omega t plus a2 cos omega t sin phi. Okay, now here apart from the omega t terms, the remaining we have to substitute by the another equation. So now see here, a1 plus a2 cos phi, we have to replace it with a r cos theta. Since it is a cos term, so we will replace it r cos theta. And this another term with the omega t, cos omega t, it is a2 sin phi. So suppose it is r sin theta. So replace these two terms in the above equation. After replacing, we will get here y is equals to r cos theta sin omega t plus r sin theta cos omega t. Okay, now from these two terms, if we keep r common, then y is equals to r into sin omega t cos theta cos omega t sin theta. Means again here we are getting the sin a plus b. So sin of omega t plus theta. So y is equals to r into sin of omega t plus theta is the resultant equation for this displacement of two waves. Okay, this equation represents here the displacement of the resultant wave due to these two waves when they are reaching out of phase at a point P. Okay, where capital R, it represents the resultant displacement, resultant amplitude, and theta is represents here the angle between the first wave and the resultant wave at that point. Okay, so it is phase angle between two waves. Okay, now we will again solve this concept to the next forward conditions. So next, see this slide. Here we are considering that how to find the value of R, resultant amplitude. Okay, so for this, that consideration equations, that means the value of a1 plus a2 cos phi, it is r cos theta, and second one, it is the value of a2 sin phi, it is sin theta, r sin theta. Okay, so we'll consider these two equations, square and add these two equations. Squaring and adding these two equations, what we will get there, r square cos square theta plus r square sin square theta is equals to a1 plus a2 cos phi whole square plus a2 sin phi square. That means a2 square sin square phi. Now solve this. We will get here, after solving I have given the steps, you observe this. Finally we are getting resultant r is equals to square root of a1 square plus a2 square plus 2a1 a2 cos of phi. This is the expression for the resultant amplitude due to two phases. Okay, a1 amplitude of first wave, a2 amplitude of second wave, and phi is the phase difference between two waves. Okay, now here we can find the angle theta also. So when we solve, we divide these two equations. When we square and add, we will get resultant amplitude. If we divide these two equations, we will get here tan theta. And what is tan theta? It is a2 sin phi and a1 plus a2 cos phi. From here, theta can be calculated. Means phase angle theta we can calculate by this tan theta. Okay, if we take the inverse, tan inverse, we will get the value of phase angle theta. Okay, now here we will consider that some cases. If two sources having the same amplitude, previously we have taken that these two amplitude are different. So suppose these two amplitudes are equal. That means a1 is equals to a2 is equals to a. Then what is resultant amplitude? Resultant amplitude, now it will become r is equals to a square, or we remove the square root. R square is equals to a square plus 2aa cos phi. Means we will get here 2a square plus 2a square cos phi. Again 2a square common from the two terms from the RHS. The remaining term is 2a square in the bracket 1 plus cos phi. Now apply the trigonometry identity here. 1 plus cos phi, it is nothing but the 2 cos square phi by 2. So substitute instead of that 1 plus cos theta, we will get here the equation to be changed as r square is equals to 2a square in the bracket 2 cos square phi by 2. So ultimate we are getting here r square is equals to 4a square cos square phi by 2. So what is the value of r then? R is equals to 2 square, taking square root both the sides, 2a cos phi by 2. So this is the resultant amplitude when both the waves having the same amplitude. Okay, so r will be 2a cos phi by 2. Okay, now we will find the resultant displacement at this position P. If r is known, now we can find the resultant displacement y. Y ची व्हॅल्यू जी आपण मगाशी फाइंड आउट केलेली होती विथ द हेल्प ऑफ r, इट इज r sin omega t plus phi. इथं दिलाय मी परत. Now substitute the value of r here. If we substitute the value of r here, r 2a cos phi by 2 आता आपण फाइंड आउट केला. So what is displacement y? Y is equals to 2a cos phi by 2 into sin omega t plus theta. This is resultant displacement. Okay, now let's find the intensity at this point P. Okay, now here the first total term represents the amplitude. R म्हणजे amplitude होता, so 2a cos phi by 2 is the amplitude. So we know that intensity is directly proportional to amplitude square. आणि original जर suppose I naught असेल तर I naught is proportional to a square. Now for resultant intensity will be IR proportional to amplitude square. Means what is amplitude here? 2a cos phi by 2. So square will be 4a square cos square phi by 2. So later next step I have written here IR proportional to 4a square cos square phi by 2. So here the two intensities are there of the original wave I naught, of the resultant wave IR. So if you take the ratio of these two intensities, take the ratio I naught by IR, IR by I naught. So here we are getting that 4a square cos square phi by 2 divided by a square only. So a square get cancelled out. We are getting here IR divided by I naught is equals to 4 I naught cos square phi by 2. This is the general equation for the intensity at arbitrary point P when the phase difference between two waves is phi. Okay, at point P, if two waves having the phase difference phi, then this is the intensity equation for that condition. Okay, so hope you understand this equation, how to find this when wave in phase, then I r divided by I naught, it is 4a square, and when it is out of phase, the last equation represents the condition. Okay, with the phase difference phi, we will find intensity ratio. So hope you understand this. If you have any doubt regarding any step here, then please comment here. We will try to solve this, or we will solve this. If you like our videos, share it, subscribe.